Cool. All right. Let's get started. So today we're gonna talk about some prediction of data from DMI. And as mentioned, I have Martin with me. And maybe Martin, you will give a brief introduction to who you are.
Sure. I'm working with BLUEFRAGMENTS, as mentioned in the introduction, and I've been working with the Azure platform, primarily IoT solutions, doing architecture and implementing solutions for the last few years, both doing the high-level architecture, but also doing like really deep into the code development, being part of that. Prior to that, I've been doing mobile development and stuff like that. So always on the most forefront with the Azure and Microsoft products for the last 10 plus years.
Mm-hmm. Yeah. Cool. And as mentioned, my name is Thomas, and I'm the CEO of BLUEFRAGMENTS. And I also am a Microsoft Regional Director. And being a Regional Director just means that I have a close partnership together with Microsoft. It's not that I'm employed by Microsoft or anything. And as mentioned, today we're gonna look at some data from DMI. And why is it that we're gonna do that? Well, we all have an opinion about the weather, and in these periods where it's almost summer and it's just been winter, and we really never know if it's gonna rain, if it's gonna be warm, or if it's gonna snow in the morning. And that was how Martin and I came up with the idea to try to build a solution where we can predict some frost. So what we're going to look at today is try to get some data from DMI. Martin will tell a little bit about the data that we get from DMI in a moment. We're going to filter the data a little bit because there's a lot of data available. And then we're going to try to use a machine learning model to do some prediction based on the data that we get. And based on that, we hopefully can say whether we're gonna shovel snow in the morning or not. And Martin, can you tell a little bit about the data that we get from DMI? And Gitte, will you try to show Martin's screen?
Yes, I can do that. It's an ongoing process from DMI releasing or making all their data public. Currently, as shown on the slide a few seconds ago, we have the observations for the weather. We have oceanic observations and lightning data available already. Those data that is being available now with an open API is raw data, as they describe it, meaning that there's no quality insurance on these data. That will come in during this year, and then they will call it climate data. And I think it was 2023, they will round up this project with doing the predictions, making that available also. Mm-hmm. As I have here on my screen, there's just a few snippets of description from the free data on the DMI site. It's really easy to get access to this. I have a link right here saying that if you Google the free data DMI, you get into the main page. On that, they show how you do a login, and they describe the entire flow, how you receive an API key, which is instant and free, and how you sign up to using the different kind of APIs that's available. So that's really, really simple. So once you get in and you get the access code, you can see that we're working with the observations. That is based on a Open Geospatial Consortium API, which is described right here. If you can see my screen, there's really simple a schema with a feature collection, and for each observation, there's some geometric coordinates and then a type of the observation and a value and a time. So instead of just looking at this really, let's say, boring schema, let's see if we can dive into something more interesting.
Yes, let's see some data.
Yeah. So first off, they have a really nice specification and documentation on how to use the API, which I'm just showing here on screen. Getting started really easy is the Swagger API. If you're familiar with doing API developments, you will probably know Open Data or Swagger as it used to be called. So in this, you can authorize and enter your API key, and then you have a sample code repository, so to speak, saying that you can just click the tryout, and then you have different examples of observations, and that will generate the URL for you that execute it, and within that you can see the response when it comes down here somewhere. Instead of using this, I would like to take you into Postman just in a few seconds. Before I do that, just coming back to here, saying that what kind of data is available. So all the observations based into or categorized into different parameters is also described here. So a lot of temperature, wind, dew points, stuff like that. So there's a long list of that, and there's also a long list of stations that is available. And this is the observation stations that is placed in Denmark and Greenland. Each of these have an ID and a location, latitude, longitude. So you just pick what location you want data from, or you could query broadly across all of the stations if you want to.
But before you actually continue on that, do you have a single point that we should get data from?
Yes, there is. We're based in next to DR-byen, but there's unfortunately no station right here. So we've chosen the Landbohøjskole at Frederiksberg, which has different kind of data that we would like to look into. And within this list here, we'll just find the ID, and then we can query the API based on that ID.
Yeah. So we actually built a simple, you can say a portal on top of all of the DMI data, right?
Yes, we have that.
Yeah. Should I try to show that?
You can do that. Yeah.
Yeah. Let me do that. Sure. Just gonna share my screen. Yeah, coming right up. Where is it? It's here. No. There. You see it? Yep. Okay. Cool. So this is actually a really simple overview of some of the data points that we get from DMI. As you can see, they are spread across the country, and here in Copenhagen we have two. And as Martin said, the one we're gonna look at today is the one located at Landbohøjskolen. And as you can see here, we have some measurements that is coming from the API. Yeah, so that was just to get an overview. So right back to you, Martin.
Sure. And right now I am showing you a Postman app, which is a developer app for calling APIs in an easy way. So right here I have the URL for the Open API, and as you can see here, I have different kind of filtering set up for this call. So let's see if we can get some observations for the latest day at Lamborghini. This is that ID. Then I have my own API key, which I'm not showing. And then I'm limiting it to 1,500 results. So just easily, that didn't work out great. Just need to switch for a different environment. If we go over here, and it's actually the same one. Then we click send, we get a result down here. Just make this one. So we get a lot of data back really fast with a lot of information regarding all the observations made in the last day for this Lamborghini school. Right now we get different kind of parameters. So that's all the different values that is recorded at this station. If we want to be more specific, what kind of data we want, we can just ask only to get the humidity, and we could also specify that we want for the latest month or the latest 10 minutes, but let's see what the humidity has been over the last day. Then we get a different kind of result set right here. Just diving into it, you can see when the observation is created, or the data is created, when is it observed, the type observation, and the ID of the station or type of the parameter, and then the actual value. These values, of course, will be different depending on the parameter type. So for this, it's a percentage of humidity. Temperature, of course, would be Celsius and stuff like that. All the documentation for that is based on the Confluence website that I briefly showed you before. The reason for that I'm showing you this parameter ID filtering is that when we want to do this prediction of shoveling snow or applying suntan lotion,
yes,
probably more relevant soon, is that we only need a few different parameter types to do that prediction.
Mm-hmm.
Yeah, and I have them briefly shown here. If I just go back in slides. So what we are basing our prediction on is this machine learning model. And for that, we need the humidity in a percentage. We need the road temperature, and we need the dew point temperature.
The temperature.
So the temperature is in 2 meters above ground.
Yeah, exactly. Yeah, and based on those three values, it should be possible to predict the dew point that we use as a foundation to evaluate whether we get frost or not.
Yeah.
Yes.
If I just quickly change back to the...
It's at the top.
Yeah. So we have that. So the basis for this prediction will be the information we just saw, the temperatures and the humidity. Based on that, we have set up different flows of handling your data.
Yes.
Yes. You can briefly talk through those.
Yeah. So actually, let me try to share my screen again here. Let me see here. Whoop. Am I sharing my PowerPoint? No. Let me share it here. Here we go. Yep. Cool. Yeah, so as Martin said, what it's all about is finding the spot that we're gonna do some prediction from. And in this case, we chose Landbohøjskolen, and we get the latitude and longitude from that. And based on those values, we can call the DMI API and get some values that we need. And in this case, we get the temperature and the humidity that we're going to use. And using those values, we can actually call our prediction model. And the way that works is that we send the latitude and longitude to our machine learning model. It's a model that predicts the weather and using a lot of different parameters based on the longitude and latitude. So we send those to the machine learning model, and we calculate the dew point based on that, and then we can try to calculate the weight for the different data series. Calculating the weight is simply that we're gonna make sure that when we have some observations and we have some predicted data, that those two, you can say, flow together, so that we don't have big differences in the prediction model. So we do some calculation on the weights on that, and finally we do some calculation on based on the dew point and on the various temperatures to try to evaluate whether we're gonna get frost and what the risk of frost. And in this case, we have chosen to do three various values: 1, 2, 3, green, yellow, red, so that when we present this in a portal, it's really easy to see whether it's okay, whether there's a risk, or whether there's a big chance of frost. So that is what we do, and you can say those 4 steps, we put that into one logic app, so that it's really easy for us to use it in our IoT engines. So maybe you should try to show how we use that, Martin.
Yeah, I can do that.
Mm-hmm.
My screen current share. No. I will easily fast. Let's see how fast it goes. Yeah, I need to click the share button myself. I'm sorry. Just quickly do that. It should be shown now. Yeah. So right here I have a Visual Studio with a C# console app, which is the most simple app you can probably start up. So what we will do now is we will quickly call the API, the DMI pre-data API, to get some values for this Landbohøjskolen. So to do that, I've made a small snippet of code right here. I'll just quickly paste that in. So first off, we get a HTTP client. We get the URL right here, which is giving us the latest hour of observations for this station. I'll just scroll down here. You can see that we have the same ID for the station as we used earlier. This will get that information. So then we will have data equal to that, like we saw before, with the different parameters and the values. So we need to get the correct values for that.
Let's try to see it. Can run it?
Yeah, sure.
Yeah,
you can run it.
Let's try to
let
see
me
it.
just output something right here. So right now it won't look that pretty, since what we get back is just string data. So let's see if it runs. Hopefully it runs. Yeah.
Yeah, a lot of data.
So we got a lot of data right here showing in this terminal window. So let's see if we can then make that a little bit more readable. So first of all, we can get those values. That was interesting for the prediction model. So we read the content right now as a string, and then we deserialize that into a model representation of the data, just meaning that we have a collection of the data in a specific way for code making it easier to read and handle. And then right here, I've just grab those parameter types that we're interested in, the humidity, the dew temperature, and I'm using the temperature at grass height right here to simulate that we have an IoT device sending road temperature, which would be useful for doing the should I shovel snow scenario. Yeah, and of course we need a little bit more code to see if we can get that printed in our terminal. So that will output these three variables. Let's run it again, see if we can get some values. That is more readable than the last output.
I think you're still outputting the first. So
yeah,
you get a lot of data in the window.
We still get a lot, yeah.
Yeah.
So if we scroll down, see we get humidity of 91%, dew point temperature 5.5, and currently they don't have any information on grass temperature. So I guess we have to cheat a little bit about that. Just this line. So now we have saying that we have the road temperature. If we cheat for that and just put in some value, we have the information that is needed to do the model prediction. So let's add some code for that. First off, I'm creating a object named convex with the information needed. This latitude, longitude is landbrugsgrund, and then we're taking the temperatures that we just found. We need that because we need to add that to our prediction model logic app. We need this information, and we're doing a HTTP post call, so we need to add that as a body. So that I will do right here in the next 2 steps. So first off, we're doing an UTF-8 encoding and getting the bytes and adding that to this post call. We read the response from this logic app, and then we'll write that as a result down here.
Yes.
So that should give us the information we need to tell you whether or not you should shovel snow in the morning.
Yes, please.
Step through this debugging section. So that runs fairly fast. Let's check the output. That's a huge output, which is not really readable. No. Sorry. I'm just gonna try that again. Apparently, I'm not trying that right now. Sorry. Well, I'm trying to grab the JSON response from our logic app and pasting it into something different so we can have a easier look at it.
But I actually think you can look at it now, right? What you have here.
Let me just quickly see if I can put it over here. No, that didn't work. So we have to look at it into this.
Okay.
If I scroll a bit. So what it says, it has latitude, longitude. It has the road temperature, air temperature, humidity, the dew point, and then it has time series. So it gives the prediction in increments of an hour, I think. Is that correct?
Yep.
Yeah. Then we have this evaluation that Thomas mentioned earlier. One being the green I would
Yes,
assume that
exactly.
everything is good. You don't need
Yep.
to go shoveling snow.
Mm-hmm.
And of course, if we look through that, this entire content, we would probably only find an evaluation of 1.
Yeah. So these days the weather is pretty good. So no reason to get ready to shovel snow. And the prediction model here predicts 165 hours ahead. And that is all of the data that you see here, where it has actually found the predicted temperature, the predicted dew point, and based on that, it has evaluated every hour for the next 165 hours. So that gives us some insight into whether we should shovel snow or not. Yeah. You're struggling showing beautifying some JSON.
If I can get it to behave the way I want to, but apparently it won't.
Okay.
So, not sure. No.
Oh, okay. Let's move ahead.
Yeah.
Yeah.
I think that was the first ever live demo not crashing.
Yeah. Okay. Let me try to share my screen again here then. Let's see some slideshow. There we go. Yeah. So all in all, we got our data. Let's see. It works. Yeah. Yeah. And as mentioned, it predicts 165 hours ahead, and evaluate the values every hour. And based on that, we can say, well, we get some data, we predicted some values, and we can say that the evaluation is 1, meaning that we do not need to shovel snow at 6 in the morning tomorrow. So all of that is really good, and is a fun thing to use the data for. But if we're going to try to look a little bit broader on this and see what we actually can use all of that data and the machine learning model to, then we can actually try to look into making some changes for our environment. So today we actually use around 300,000 tons of road salt every year, and it's just being spread out on well, almost all roads throughout the country. I know that some but a lot of them also just salt based on experience and based on what they did the last couple of years. In total, we actually spend around 1 billion kroner on salt, on people being on watch and doing the salt. So there's a lot of cost that can be saved if we try to look into how we can predict the frost, and based on that choose where to salt and where not to salt. But there's also this big environmental win doing this, because some of the things that is happening with the salt is that it actually just runs out in the nature and in the ground, and that's not really good for the environmental environment. So there's a big win if we can actually try to limit the use of salt, and that is some of the things that we are trying to do using this prediction model. So what we are actually doing is we built this IoT platform that makes it really simple to collect a lot of data. In this case, we use some of the data from DMI. We use it to predict, as shown here, and to present the data so that the municipalities actually have some insights into whether they should salt or not, and where they should salt. And they can actually also use all of this prediction data to use that as input into other apps, so that the data can actually live on. And right now, a lot of the municipalities are looking into it, and some of them are already using the data to make it even smarter. And we build a solution called Intelligent via Park for the municipalities to look into that. So if you're interested in that, I recommend taking a look at dataplatform.dk, where it's possible to get some insights into how that is done. And with that, I actually think that we have really tried to show how do we collect data from DMI, how do we process them, how can we use them to make some business value, not just for me and whether I need to shovel snow tomorrow, but also how, for example, municipalities can use it to save money and have a more green profile. I know that there have been a few questions, and I think Gitte have shown that here. So where are these predictions used, and can they be set up with other data sets? Yeah, so one of the things that we actually do is, let me try to find that, just a second. Let me show you here. Let's see if I can share my screen. That. Go. Can you see that? Yeah. So here we are. This is the overview I also showed before. We are collecting the data from DMI and actually just presenting them in this portal. And in this case, we use that as input to the prediction model, and we can also use this together with a lot of other data sets. We talk a lot with, for example, municipalities that have their own sensors spread out through the entire city, and based on that, they get a really good insight into the road temperatures. They can see whether the toilets needs to be cleaned, stuff like that. And we can actually cross that with data for other data sets like DMI. Let's see what we also got.
I can take the next one. The machine learning model is not from DMI because, as mentioned in the beginning, these machine learning models or the forecast are not available yet. That will be available sometime next year. So right now we're using an external model for that we have available.
Yeah. So maybe I should. So we don't have any you can say work or partnership with DMI. We're just using the data, and we thought it could be really beneficial to use that data together with that prediction model that we're using with another partner. So you can say we use the DMI data here to predict based on their road temperatures, but some of the municipalities, for example, have their own sensors, as mentioned before, where we use that data to predict the data.
pay attention to the map in the portal right now, you see the red circles. That's the stations from DMI. So if you want some local prediction on road temperature in Ringsted, for example, where I'm from, there's no station near that. The nearest one is Roskilde or
I'm not sure.
Not even close.
Let's
So of course, if you want a precise or close to precise prediction, you need to have some local sensors available with data on road temperature and stuff like that.
Yeah, and that is some of the things that we're actually talking to the municipalities about, is that it's really good to have data like this from DMI, but they need to combine it with their own sensors. So what we see is that the municipalities actually buy a lot of, for example, road sensors and spread that out through the city so that they have a really good insight into where to solve the roads, for example. Regarding the time horizon for the prediction, it's 165 hours that we can look ahead. And of course, as any other prediction, it's pretty good initially, and the precision of the model, of course, gets a bit worse as time goes. Yep. They have a historical database of live data. How far back do you consider these as input for your model? Yeah, so what we are using in this demo is actually just the latest observation that DMI have. And we are not using DMI data to train the machine learning model. We're using some other data for that. So in this case, we're just using the latest observation. Is it possible to use prediction models in your solution, or should you bring your own model? So you can say in this case and in our IoT platform, we make it possible to either bring your own prediction models or actually use some of the models that are built in. And one of the models that are built in is this one that we use to predict frost based on historical weather data. Have you evaluated the accuracy of your prediction? Can the color codes be associated to confidence intervals? Yeah, so that is actually a really good question. So we are continuously evaluating the model. So it's been evaluated all the time based on historical data. And the way that we currently color code the evaluation 1, 2, 3 is based on you can say some calculations made together with the company that makes the machine learning model, so that we're really sure that we get the evaluation right. So yeah. Can you say a few words about the machine learning model type? Well, no, to be honest. So we're using a machine learning model that comes from an external company that we bring in to this platform, and I won't try to go into the insights of that machine learning model. I haven't worked on it, so no, I won't do that. Sorry. Do you store any data yourself, or is it handled on the fly as needed to be displayed? Yeah, so in this case, the data that we get from DMI is actually just used and evaluated right away. Normally, when we talk to a municipality, for example, we collect that data and we store the data in a data store located at the customer. Some customers prefer to have it in their own cloud service. Some prefer that we take care of it. So it's totally up to the customer to decide where to put the data. And we, of course, doesn't store any data unless we get the permission from the customer to store that data. And in this case, with the DMI data, we just use it on the fly. Yeah, so we do make machine learning models ourselves. I'm not. So that is why I'm not trying to go into the types of machine learning models that we're using, but we are doing it ourselves and put those into the portal. So yeah. Any other questions? No. Any from YouTube? No. That is where they're from. Perfect. Well, let me share my PowerPoint again then.
You seem to be frozen in time.
Yeah, awesome. Let's see. It's right here. There we go. Okay, so if you got any additional questions, you're of course always welcome to reach out. You can either do that to me or to Martin. And we will make the slides available afterwards. And as mentioned, if you want to try out our IoT platform, you can do that for free at dataplatform.dk. You can get a free version running. And with that, I think I would say thank you so much. It's really been great to be back after a few months of break. It won't be long until we have the next IT People event, I know. Right, Gitte?
Yes, we will get back to you with more information about that.
Yeah, perfect. So with that, I will say thank you so much. It's been great, and have a really great day.